Houston II serves as Managing Director of the Facilities and Building Manager Software Commission. Mr. Houston is both a seasoned mechanical systems engineer and IT security professional. Please welcome James to Stage 2.
So, who are you in the facility or your controls company hierarchy? You are one of these three people: the capitalist, the hard worker, or the leech. Now, I'm going to assume because you made the effort to come to Miami from wherever your home destination is, that you are the hard worker. So, no matter what role of the three you play, you have a responsibility to your organization, and you are failing at it. You are either focusing on your personal profit, focusing on your work without regard to who's using it, don't give a damn because it's not your problem. End result, you're burning money. So let's get started by understanding the people and systems we use that make up a facility. And so just a moment ago when I was talking about creating the tools, the hard worker that creates the tools, we do some amazing things in ICS and SCADA security. The problem is sometimes we have our head down and our nose so close to the grindstone that we're not paying attention to who is using the tools we create, and if they're even using them correctly. So, first let's start with the system overview. What components are necessary to run and maintain a facility? We need a facility, industrial equipment, and a stationary and/or building engineer. The current state of our industry requires that we understand the changing landscape of a facility and the individual role within that landscape. What skills must they possess to assess in our overall goal of ICS and SCADA security? To do this, we must first understand the problem and challenges facilities encounter, identify what skills these problems and challenges require, identify our stationary/building engineer's role in the facility, address industry hiring practices. So understanding the problem. Issue number one is our naming convention. You can be a boiler operator, a service technician, serviceman, an HVAC technician, a plant operator, a stationary engineer, a plant engineer, a maintenance man, or a building engineer. Now, the yellow indicates the terms we use most often, which is stationary and/or building engineer, which I'll be using throughout this presentation. So all these positions, qualifications, have HVAC as the single thread connecting them, but two specifically use engineer in the title. Now, where have I seen this before? And when I created this, I didn't realize the poetic justice of being in the Jackie Gleason Theater. So, The Flintstones, Moonlight Maintenance, Season 5, Episode 20, Fred gets a job as a sanitation engineer at the Rock Hotel. For those of you who don't know, the Flintstones are based on the Honeymooners. So, back to our issue. Who has been labeled an engineer? Station engineers and boiling operators typically learn their work through long-term on-the-job training under supervision of an experienced engineer or operator. Some station engineers and boiler operators complete apprenticeship programs sponsored by the International Union of Operating Engineers. These are the people that are using the tools that you create. Now, I want you to think about your training process and the engineering or computer science struggles that you went through, and if you would have been able to get that through just going through some apprenticeship, sitting behind somebody, carrying a tool bag. So, further understanding the problem. What is HVAC? By definition, HVAC is a system used to provide heating and cooling services to buildings. Who then is qualified to deal with HVAC services? According to job listings from companies across the country, someone with a high school diploma, an EPA 405 license, and/or a boiler license. What then is the definition of service? To repair or provide maintenance. So, issue 2, repair and maintenance. Maintenance has changed over the years, but we haven't changed with it. From a traditional standpoint, maintenance for a boiler can be summarized in 5 steps. Check the sight glass, check the pressure gauge, blow out the mud drum, chemically treat the water, write in the log. So we're just going to stick with a boiler. As we all know, there are many pieces of equipment in a facility, but that's just a boiler. That's just the maintenance for a boiler. So now if we look at the Cleaver-Brooks maintenance manual, electrical components is the only thing that is in their manual that is not a mechanical belt-driven piece of the equipment. So if we drill down to these details, we find that the language says that it's made semi-automatic or automatic so that it can take operations away from the operator but not take away the responsibility of maintaining the system for the operator. So this is our first introduction to an additional skill set that our technician must have that is not part of our original skills described earlier. We're also starting to see the emergence of automation. So remember, this is a 20-year-old manual. How have things changed, this piece of equipment, over the last 20 years in terms of technology and additional functionality added? Let's look at a newer boiler and see what it takes to operate and service it. So now we're looking at the Cleaver-Brooks CBX Dryback Elite. It looks identical, except there's one huge difference. So the Dryback Elite throws in the added advantage of a user interface that has logic-based auxiliary development and functions. So we have now incorporated logic controls to our boiler. Let's look at the new manual and see if our maintenance section has changed. It's the exact same boilerplate language that talks about making it automated for the technician or boiler operator. So how is this possible if the machine has gone through 20 years of change? The maintenance can't be the same, especially if the major change is software-controlled automated hardware. So if it's automated and can report everything that's going on, then is our technician still relevant? Yes, we still need hands and eyes on the machine. As we all know, as we run these systems, the computer will lie to us. It will give us false readings. If you've ever had an opportunity to deal with a pump that is reading well but it's not working, and you walk over to it and touch it, it's extremely hot because something's wrong with that pump, but it's reading that it's fine. So who then performs the maintenance on the automated control system that we now have on this boiler? The current solution is to use a third-party firm. So now we'll use a service contract from, say, Cleaver-Brooks, and they'll come in and they'll do maintenance on that piece of equipment. So the yellow indicates new maintenance by our third party. So now they'll clean the sight glass, they'll open the mud drum and clean it out, they'll change out the gauges, they'll open the boiler to make sure corrosion is not taking place. That is the added functionality of using that service contract. Possibly update software and user interface through an external Ethernet port. Quick story. I was working for the University of San Francisco, part of the engineering team that brought on Benioff Children's Hospital. I'm sitting around with some guys that have been in the HVAC industry for about 25 years. They've worked their way up to be labeled stationary engineer. Something's wrong with the boiler. Now, what they're used to is walking over to the boiler, hitting with a ball-peen hammer or some form of physical maintenance. So we have what looks like a 13-year-old walk in. Plugs into the Ethernet port, resets the software, boiler takes off. I got guys 25 years in the industry that mouse hit the floor because they could not compute what had just happened. That's not how you fix a boiler. So now if we look back at the system and necessary maintenance, what does it look like? Now we have a first party, that is our stationary build engineer. We have a third party, that is the service contract people that we bring in to perform the site glass cleaning, gauge changing out, things of that nature. But we also have an additional party, because now what we are introducing is a monitoring group. And now that group will be monitoring our building automated system. So we have 3 different entities that are now looking at the same system. This can't possibly be cost effective. So let's look at the cost analysis. Our building engineer has an average salary of $54,000 and change. So I did that for Miami because I was going to be here. The boiler yearly maintenance, about $100, $200 to have them come in and just kind of look over it. If they have to do any repairs, then of course that cost goes up. Service contract with the HVAC service firm, price based on square footage. So we're looking at about 25 cents to $1.25 per square foot for the facility. So an example, the Miami Beach Convention Center at 1.2 million square feet at 25 cents is $300,000 on the low end, and 1.5 million at $1.25 on the high end for that company to come in and service that building and the equipment within that building. So we go to our BS monitoring operational support. This is not SCADA or cybersecurity or ICS security. They are just monitoring our software. So for a small IT service firm, pay anywhere between $100 to $395 per month for that service contract. So at 12 months, we're looking at either $1,200 or somewhere around $4,700. So I know some of you pay a lot more for that service. So cost analysis continued. So our stationary engineer is at $54,642. Our boiler yearly maintenance is $100. Our HVAC service contract is $300,000 on the low end. Our BS monitoring is around $4,700. So that's a yearly total of $300. Actually, you will always find an error because you can't have $300,000 when you have $300,000 as one of your things. So I've got some engineers in the group. I'll let you do the math. The point is, we are really burning cash for these additional services to look at the systems that we already create. So how do we address what the facility needs with our engineers' skill sets? So if we look at that again, we end up having, and this might be a little light for you guys, we have that we're asking in the job description for a stationary engineer that they have a high school diploma and that they have some form of HVAC background. Based on our facility needs, our current employee no longer is able to service our equipment. However, the person with the skills that we need to fill this position is available. So let's update our skill set for the needs, the new needs of the facility we require. That is mechanically inclined, firm understanding of HVAC equipment and systems, computer science, C++, Linux, and/or Python, network monitoring, Microsoft Linux, different protocols, BACnet, you can even throw Cisco systems in there. So who can fill this void? Engineers, mechanical and network engineers that can be cross-trained. So I don't want anybody running out when they see this course load, because some of us had to deal with it, right? But we're talking about people that they have gone through the logic process, Cal 1, Cal 2, Cal 3, differential equations, intro to C++, C, communication networks, network system designs, operation theory, probability, decision risk. So according to the Bureau of Labor Statistics, engineers are available. However, they won't take our jobs, right? They won't take the building engineer job. So it says that the hiring rate of engineers is so high that they're taking these fantastic jobs at the Boeings of the world and the Lockheed Martins, et cetera. But that's only to the untrained eye. The U.S. Census Bureau reported that 74% of those who have a bachelor's degree in any type of STEM are not employed in that industry. So, how is this possible? Let's look at what a new engineer faces upon graduation. So, a mechanical engineer upon graduation, they say you'll be able to make about $50,000 to $60,000 a year starting out, but they want you to have 3 to 5 years experience. Network engineer, once again, 40 to 50 on the high end, and they're saying that you need a minimum of 2 years experience. Not only that, we're going to require that you have these certifications, at least 1 or 2 of them. So it's not possible to graduate, have 3 to 5 years experience and or 2 years experience, and the certifications necessary to get into your own industry. So what we see is this is for a somewhat seasoned engineer. So a deeper look at mechanical engineer shows that if I go ahead and say, okay, let's just do entry level. What entry level ends up telling us is that there are going to be more jobs that come up through the search algorithm for a building engineer than a mechanical engineer, because their backgrounds or what we're asking from them correlate. So this doesn't make sense. How can their skill set be for the same position? I just put up what our engineers are going through. And then earlier I said somebody's going through an apprenticeship where they're following around somebody, they're carrying tools, they're kind of learning how the machine works. But their skill set, as far as we're concerned, is the same. So this shows that the mechanical engineers are the best fit, and we can cross-train network engineers. We also know why engineers are going into different fields upon graduation. They don't meet the criteria to enter into their own industry. So, do a quick comparison chart between our stationary engineer and our mechanical engineer. So, upon graduation, for the HVAC technician or the building engineer, we're looking at 54 and some change, and for the mechanical engineer, we're looking at 58 and some change. Now, what we're asking of them for the HVAC tech or the building engineer is that they have knowledge of building mechanical systems, knowledge of HVAC systems, knowledge of OSHA standards, knowledge of local fire codes and other codes, deal with discussions and things like that, and the ability to perform basic intermediate math skills. For our engineer, what we're asking is that they can do HVAC load balance calculations, they can determine system sizing and layouts, knowledge of drawings, construction, as-builts, and be able to do high-level mathematics and logic. So if we put that same building engineer versus our network engineer jumps up a little bit, and now we're looking for them to do configurations, deployment, install network hardware, understand network monitoring, and provide level support for LAN and WAN systems. So to upgrade to an engineer is, for the mechanical side, around $3,900, and for the network side, around $7,100. We can all agree this is pennies on the dollar for what we get, and you can keep the employee by raising salaries in the future. So how? We got to trim the fat. We have to eliminate third and sixth party systems from doubling back over systems that we're already looking at. So by eliminating redundancy, that is where that cost is covered. So now not only can we give that engineer a salary that is competitive, we can afford to give them salary increases to keep them. So now we can reasonably expect from our team of engineers to deploy and maintain BS maintenance and security, mechanical and electrical maintenance, logic and decision risk assessment skills, back-end programming, networking and being on the same page as our IT department with a BS focus. In addition to our initial stationary building engineering skill set of checking the sight glass, checking the pressure gauge, checking out, cleaning out the mud drum, chemically treating the water, and writing readings in the log. So, final thoughts. As an industry, we are slow to change, and we have incorporated technology without adjusting our current practices to implementing these changes. We continue to do brilliant work, but it's lost on the people that use it. We are spending without regard on third and sixth party firms to do work we can do ourselves without the liability associated with the responsibility. Redundancy is costing a fortune. So here's an example. Our in-house engineers are watching our system and controls. A sixth party is watching the same controls. If there's an incident, their system goes black and we are left to get back online. Watching out for malicious activity is not the same as testing or preventing malicious opportunity. So I'm not quite sure how many have spent time in a mechanical boiler operator room, but they are watching these systems consistently. Changes in pressure, changes in flow, if something goes down, dealing with preventative maintenance. But then we still pay for somebody to watch the pressure and the same flow and to notify us about preventative maintenance. So, the money saved, as I said, could be used for not only boosting engineer salaries so that we can get them in the positions we need for a better, secure facility, but also for those infrastructure upgrades. So dealing with some of the issues that my salespeople deal with that have come to the conference is that you build these amazing PLC security controls and you go out, or your salespeople go out and they say, hey, we can't afford that. You say, well, wait a second. I just came back and James told me you need to trim the fat. So I'd like to point to what I would consider ICS SCADA 101 reading. For those of you, it's the Critical Infrastructure Interdependencies by Randy, Pienerboom, and Kelly. This is from 2001. I know there are a number of people that are familiar with this document. In this document, they talk about, this is from 2001, and they talk about all the security and the interconnectivity, but they fail to touch on the human activity with these systems. And this is who is touching our systems. So I have one more story for you. I was overseeing an energy system for a major university. I go in and I'm talking to the building engineers that work on the system. And we're discussing security and they kind of looking at me funny. And I talk to the guy that's actually watching the facility. I find out that he did not pass the 6th grade and he's a functioning illiterate. He's made it this far, which is fine. He's a laborer, he's doing his job, but the system has changed, and he has grandfathered his way in over time. And once again, we're putting these systems in his hands and asking him to be able to deal with what we saw this morning in virtual ghost twins and, right? This is what we're asking. So I got a few seconds left, and I understand in a room full of cyber-inclined individuals that this has been a non-technical session. So before we end, I'd like to give you the most important hack of all time. So if you have your pens ready, I'm going to give it to you. Up, down, left, right, A, B, select, start. Thank you.
Thank you so much, James. Does anybody have any questions?